In this video, we will review how to do some matrix operations by hand. So for problem number 1, part A, we need to do A times B plus A. Let's start by doing matrix A times matrix B. Now here's a little bit of dimension analysis. Matrix A is a 2 by 3 matrix, 2 rows, 3 columns. Matrix B is a 3 by 3 matrix, 3 rows and 3 columns. For matrix multiplication to be possible, the inner dimensions have to be the same. So I see that I have the dimensions of 3 and 3 are the inner dimensions. So that means this is possible. The outer dimensions are also important because the outer dimensions tell me the dimensions of the product. So the product of A times B will be a 2 by 3 matrix. That's very important because that tells me that I need to set up a giant 2 by 3 matrix in order to do the problem. So that's what I'm going to do now. So here's a very large 2 by 3 matrix. All right, I'm going to draw these lines to show that I have 2 rows. And here I will demonstrate 3 columns. All right, now here's what I do with this. The rows are going to come from matrix A. So the rows are going to come from here. So here I have row 1 and row 2. Row 1 goes in row 1. So I'm going to take this 2, 3, and 4, and I'm going to put it all throughout row 1. So I'm going to have 2, 3, 4, 2, 3, 4, 2, 3, 4. All right, row 1 goes in row 1. Now row 2 will go in row 2. So row 2 is negative 1, 4, 0. So I'm going to have negative 1, 4, 0. Negative 1, 4, 0. Negative 1, 4, 0. Row 2 goes in row 2. So now the columns are going to come from matrix B, the second matrix. Okay, so I have column 1, column 2, and column 3. Column 1 goes in column 1. So 3, 1, 4. So I'm going to have 3, 1, 4. And I will put that throughout column 1. So I'll have another 3, 1, 4. Column 2 goes in column 2. So 5, negative 2, negative 5. 5, negative 2, negative 5. 5, negative 2, negative 5. And finally, column 3 goes in column 3. Negative 2, 3, 1. So negative 2, 3, 1. Negative 2, 3, 1. Finally, what I need to do is multiply and add. So if I multiply these, I'm going to get 6 and 3 and 16. Similarly, if I multiply all of the other numbers, these are the numbers that I get. And finally, I need to add. So if I add up 6 and 3 and 16, I'm going to get 25. So this is really the answer for this element. Okay, is 25. And similarly, I will add up all of the other purple numbers here. All right, so these numbers that I put in the little boxes are the answer. All right, that represents the product of A times B. So I'm just going to go ahead and copy that down right now. So I've got 25 and negative 16 and 9. and 1 and negative 13 and 14. Now usually at some point I make a careless mistake with my multiplication and addition. There's just so many opportunities to make a careless mistake, so you know, it's going to happen. What are you going to do? So now I've got the product of A and B, and I still need to do plus A. So that's what I'm going to do now. Okay, so here's matrix A is 2, 3, 4. So I've got 2, 3, 4, and negative 1, 4, 0. So that's negative 1, 4, 0. Now, to add two matrices, the dimensions have to be exactly the same, which luckily is the case right now. So this is doable. And the sum, of course, you're just going to add the corresponding terms. So, for example, if I do 25 plus 2, that's going to be 27. So I'm just going to keep going and add all of the corresponding terms. So this is what I'm getting for the final answer. All right, next we need to do the product of matrix A times matrix C minus 2 times matrix D. All right, so let's see what we can do. So first of all, let's do our dimensional analysis for the product of matrix A times matrix C. Okay, so matrix A is a 2 by 3 matrix. So I'm talking about a 2 by 3 matrix times a 3 by 2 matrix. So I've got a 3 by 2 matrix. So for this product to be valid, the inner dimensions must be the same, which they are. But then, very important, the outer dimensions tell me the dimensions of the product. So matrix A times matrix C will be a 2 by 2 matrix. So let's go ahead and set up a large 2 by 2 matrix in which we will do our work. So here comes a very large 2 by 2 matrix. Okay, and this is all for matrix A times matrix C. So again, the first matrix gives us the rows. The second matrix will give us the columns. Okay, so the rows will come from matrix A, and then the columns will come from matrix C. Okay, so row 1 is 2, 3, 4. So row 1 will go in row 1. So that's why I'm going to have 2, 3, 4. 2, 3, 4. And that's it. So now row 2 is negative 1, 4, 0. So row 2 goes in row 2. So negative 1, 4, 0. Negative 1, 4, 0. So now it's time for the columns. Column 1 goes in column 1. So negative 2, positive 2, negative 3. Okay, and column 2 goes in column 2. So negative 1, 0, 3. So negative 1, 0, 3. Negative 1, 0, 3. Now it's time to multiply and add. So if I multiply these, I'm going to get negative 4 and 6 and negative 12. Similarly, if I multiply the rest of these numbers, I will get these purple numbers that you see here. So now it's time to add these up. So for example, if I add -4 and 6 and -12, together that makes -10. And that's really the answer for this element. Similarly, if I add up the rest of these purple numbers, this is what I get. So that means the product of A times C is going to be the matrix -10, +10, +10, 1. Okay, so this is just the matrix A times C. Now we're supposed to take this and subtract 2 times matrix D. All right, so we're supposed to have matrix 2D next. So here's matrix D. So multiplying by 2, we're just going to double all of these numbers. So that's going to, of course, give us 4 and -8 and -12 and -22. All right, so that's 2D. So here we have AC minus 2D. So when you subtract, we're just going to subtract corresponding terms. So we're just going to do -10 minus 4. So, of course, that would be -14. Now be careful on this next element. We have 10 minus -8. So remember, if you do 10 minus -8, that's really the same thing as 10 plus 8. So that's why this element is going to be 18. So watch out for the whole minus a negative thing. So again, down here I have 10 minus -12. That's really 10 plus 12. So that's going to be 22. And one more time, I have 1 minus -22. That's really going to be 1 plus 22. So that's going to be 23. So this should be the final answer.
Good morning, Mr. President.
Good morning, George. So this little t stands for transpose. So this means D-transpose. So D-transpose just means that the rows become columns and the columns will become rows. So row 1 is 2, -4. So that will now become column 1, 2, -4. Row 2 is 6, -11. That will now become column 2, -6, -11. Okay, so this is D-transpose. Ha, my little tablet was crooked, so I'm writing crooked. Please forgive me. So now we have to take that and multiply by matrix E, which is, of course, 4, -8, -1, 2. Okay, so this will be D transverse times E. So what we need to do is our dimensional analysis, where we see that this is a 2 by 2 matrix, and this matrix E is also a 2 by 2 matrix. Of course, the inner dimensions are the same. That makes this possible. The outer dimensions tell you the dimensions of the product. So the final answer should be a 2 by 2 matrix. So that lets us know that we need to go ahead and set up a rather large 2 by 2 matrix. All right, so that's what I'm doing right here. All right, as we've done on previous problems, the rows will come from the first matrix, and the columns will come from the second matrix. Okay, So row 1 goes in row 1. So that's why I'm going to put 2, -6, 2, -6. Row 2 goes in row 2. So that's why I will put -4, -11, -4, -11. All right, now the columns. Column 1 goes in column 1. So I will put 4, -1, 4, -1. Column 2 goes in column 2. So I will have -8, 2, -8, 2. Now it's time to multiply and add. So I'm going to get 8 and +6. Similarly, if I multiply the rest of these, I get these purple numbers you see here. Now if I add, for example, 8 and 6, I'm going to get 14. So that is going to be the answer for this element. And similarly, if I add the rest of these numbers, I get -28, 10, and -5. So that gives us the final answer of 14, -28, -5, and 10. And finally, for part D, we need to do matrix C times matrix E. But the first thing we need to do is our dimensional analysis. So matrix C is a 3 by 2 matrix, and then matrix E is a 2 by 2 matrix. For this to be possible, the inner dimensions must be the same, and they are. And then the outer dimensions tell us the dimensions of the product. So our final answer will have dimensions 3 by 2. So that's very important because that tells us that we need to set up a large 3 by 2 matrix right now. Okay, so here we go. So we have to have 3 rows, 2 columns. All right, so we're all set. Now, as you've seen before, the rows will come from the first matrix, and the columns will come from the second matrix. Okay, so row 1 will go in row 1. So that's why I'm going to put -2, -1, -2, -1. Row 2 goes in row 2. 2, 0, 2, 0. Row 3 goes in row 3. So we have -3, 3, -3, 3. Okay. Now let's do the columns. So column 1 goes in column 1. So we will have 4, -1, 4, -1, 4, -1. Column 2 goes in column 2. So that gives us -8, 2, -8, 2, -8, 2. So now it's time to multiply and add. So for example, if I multiply here, I'm going to get -8 and +1. And similarly, if I multiply the rest of these numbers, you get the purple numbers showing here. Now, if I add -8 and 1, that of course will give me -7. That's going to be the answer for this particular element. Similarly, if I add the rest of the purple numbers, I get the numbers in the boxes you see here. So that's why the final answer is going to be -7, 14, 8, -16, -15, and 30.
Can I leave my backpack in here?
So that's the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.